is being recorded. What the heck? What about now? Still no? Can other people hear me? Can I not be heard at all? Oh, that's good. Somebody can hear me.
I can hear you also.
I'm sorry. I'm gonna test my stuff. Testing. Yeah, I heard myself. So I'm gonna assume we're good to go. Okay, let me share my screen. Hector, I'm gonna turn your video off just because the less things I have open, the faster my computer runs. I might even turn my video off too. Boom. Okay. Okay, we want to pick up. We want to, what the heck? We want to, nope, that's not what I want either. Let's go back. The heck? Where's my zoomage? Cannot minimize. Yeah, I get that. Share screen. There we go. Share the screen. Not my emails. Boom. Okay. There we go. That should be working now. Okay. So last time, okay, we talked about proportions. Today we want to talk about sample means. Okay, so for a proportion, remember it was the Z, two sample Z test. We're using Z's, okay, on the proportions. Okay, for means, okay, for means we use T. Okay, for proportions we use Z, and for means we use T. Okay, for means, maybe I'll write in a different color today, since we're talking about means. What would be a good color? Maybe a dark blue would be good. Sure. Okay, let me erase this. We'll do means. Means is T. Okay, so we're gonna focus on means today. Okay, so we're gonna talk about what is a two sample T interval, how we get that, and what's a two sample T test. Okay, two sample T test. Okay, used to compare two independent populations. They're independent. Okay, we'll talk about later what happens when they're dependent, but for now we're going to talk about what happens when they're independent. Two different populations, like men and women. Okay, what would be a dependent population? That would be like siblings, or you're comparing husband to wife. They're dependent on, their behavior can be somewhat dependent on each other's actions and reactions. And that's
like children?
And more like siblings, right? So you would compare sibling to sibling. They would be paired basically up, right? You'd say this family, I'm gonna compare the boys in one family to the girls in the other, but you would pair them up by family. Within that family, you wouldn't compare them. You wouldn't compare them just randomly. Okay, it would be a pairing. Okay, it'd be like spouses, right? So you'd have all the husbands and wives. They would pair up with each other. Those would not be independent populations. Those would be dependent populations. Okay, because there's other variables, confounding variables that are going into play there. Okay, it's not a random assignment. I'm not just throwing all the guys in one pit and all the girls in another pit and saying, oh, how do they compare? No, I'm saying, look, I'm going to compare this couple to this couple to this couple. So again, it's a dependent, that would be dependent. Here we're just going to talk about independent, okay, independent pairings of averages, okay, the average weights of babies at 3 months, right? How do they compare in one country versus another country? Okay, so example questions. Are IQ scores for people who attend college different from those who do not want to attend college? So all we're looking at is the difference here, different. Okay, so if it's just different, then this would be a hypothesis test. Okay, or what we would call a t-test. Okay, that's a t-test or a hypothesis test. Okay, now this number 2 is asking me how much. It's looking for a value or a range of values. It says how much taller are men on average compared to women? We're comparing the men to the women, and how much taller. We're looking for a value. When we're looking for a value, okay, then this is a interval or a t interval. This is a confidence interval. Okay, so those would be, what's a t? Okay, mean. So we'd find the means for men and we compare them to the means for women, the average for men and the average for women. Okay. Okay, how would we get standard error? Okay, because for a hypothesis test or for a confidence interval, okay, for a confidence interval, it would look like this. Okay, we would get mu1 minus mu2 plus or minus t star, okay, times my standard error, my standard deviation. Okay, and in this case, it's this. It's sigma squared 1 over n1 plus sigma squared 2 over n2. I'm comparing the standard deviation of one population, okay, over n, to the standard deviation of the other one, okay, squared over the number of items in that second population, and then I'm adding them together, square rooting the whole thing to get my what's called standard error. Now, you will not have to do this by hand. We're going to let the calculator and StatCrunch do this for us, especially since the next computation is rather complicated and convoluted. Okay, to find the degrees of freedom, it's not as easy. Remember, the degrees of freedom before was n minus 1, right? That was simple, n minus 1. So if I had 30 in a group, the degrees of freedom would be 29, right? That's simple, easy peasy. And not so simple when we have 2 of them. When we have 2 of them, we have to take the sample standard deviations, square them, divide, and then take the sample standard deviations squared, divide by n minus 1, plus the sample. This thing is extremely difficult to crunch. And so we let the calculator do that for us, where this is on the calculator. We'll do this for us. Okay, so we're not going to be doing this on our own. Okay, we're actually not going to be doing much of anything on our own. We're going to plug in the values that that the scenario gives us, and we're going to let the calculator calculate the p-value. That's it. We're going to let, because it's too complicated to sit there. This would be a half-hour problem each if I tried to just get the degrees of freedom. Okay, and so we're going to let the calculator get the degrees of freedom, and we're going to let the calculator get the standard error. By getting the degrees of freedom, we're going to let the calculator also calculate t star. It is able to do all of those. Okay, so yeah, so let's do that. Again, you don't have to memorize these formulas. Actually don't. I would encourage you not to, unless you are really bored or in self-quarantine for 14 days and you absolutely want something to do. Go ahead and memorize it, but I wouldn't suggest it. Okay. Let's go to example 2 here. Okay. Example 2. It says, 2 researchers investigated the reliability of test assessment. One group consisted of 30 students. The second who took proctored tests. The second group consisted of 32 students who took tests online without a proctor, or without a proctor. Okay, so without a proctor. The 2 samples were taken independently and not paired or matched. Okay, they're not paired. Okay, they're not matched. There's one group of 30. They were all proctored. Okay, meaning that they were oversawn. Oh, I don't think that's a word. They were looked over by a instructor, or somebody oversaw. Yeah, that's better. Someone oversaw them taking the test. Okay, they were monitored while taking their test so that they don't cheat. And then 32 students who took tests online who were not monitored. Okay, so a little sketchier. Okay, here's the summary of the results. Okay, we want to know, is there any significant difference between group 1 and group 2? So group 1 had 30 people. The average score was 70, and the standard deviation was 22. In group 2, they had 32 people, average score of 74, a little bit higher, a smaller standard deviation at 18.5. I want to know, is there a significant difference between the mean scores? Now, am I going to use an interval or a hypothesis test? Here it says estimate the difference. So I'm actually looking for a value. And when I'm looking for a value, that is an interval. Okay, that's an interval, not a hypothesis test. So what are we looking for in our interval? Okay, so in our interval, flip the page. Okay, we are looking for how the two groups behaved, right? What we're comparing the means. We want to compare the averages. Okay, I want to compare the averages. Now, we can see that the average went up, right? We can see that the average went up. The average went from 70 to 74. And I want to know if that's significantly, you know, is that significant? Is there a significant difference in the two groups? Well, it's just easier for me to think of group 2 minus group 1. Now, why is that? Why is group 2 minus group 1? Okay, it's easier for me to think of group 2 minus group 1 because that will leave me with a positive result. Okay, right? We're comparing the averages mu1 minus, okay, minus mu2. Okay, and I want to see, okay, are they equal, right? Are they equal? Okay, or is there a difference? Okay, so I want to estimate the difference between the mean scores. So mu1 minus mu2, are they the same? Are they equal to 0? Or is mu1 minus mu2 not equal to 0? Is it different? Is it right? So actually I'm just gonna keep it as group. I'm not gonna confuse it. I'm just gonna do group 1, okay, minus group 2. And if it's negative, it doesn't matter. If it's negative, it just tells me that it's not equal. Okay. So group 1 minus group 2, just to keep it simple. I don't want to confuse. I don't want to reverse it just to keep things positive. Okay. So how are we going to use an interval to help us do this? Well, we're going to use the calculator or StatCrunch, and we're going to say the two sample. This is a two sample t interval. Okay, two sample t interval. Okay, and then we have to check the conditions. Is it an independent sample? Yes. Is it random? Yes. And are both of them at 30 or above? Is n1 greater than or equal to 30? Yes. Is n2 greater than or equal to 30? Yes. Okay, so they both check. Okay, so now we're going to go to the calculator and get my results. So let me bring up the calculator. Oh, let's bring up my calculator here. Any day now. Thinking about it. What's slowing me down? This is probably slowing me down. Say goodbye. There we go. Okay, got my calculator out. Clear. And I want to do, oh great, I got multiple calculators out. Oh, they keep multiplying like little rabbits. Okay. So second stat, no, what do I want? I don't want second, I just want stat. Just want stat, and then tests, and we want the two sample t-test. Where's the two sample t? Oh, it's number 4. It's number 4 on the calculator. Two sample t-test. That's what I want. Two sample t-test. No, I don't want a test. I want an interval. Gosh darn it. I want the interval. Here, it's 0. It's 0. Two sample t interval. Yeah, I gotta make sure that I'm getting the right one. Okay, two sample t interval is what I want. It's 0 on the calculator. So what do I want? I want statistics, not data. Okay, and I want to know x1. How many? That's right. Yeah, x1. Okay, what's my x bar 1? What's my average in group 1? My average in group 1 was 70.29. 70.29. Okay. Okay, what's the sample standard deviation? It's 22.09. Okay. And how many were in the first group? Well, there were 30 in the first group. Okay, x bar 2 is 74.26. SX2 is 18.15. Okay, and N2 is 32, I believe. Yeah, 32. Okay, what's my confidence level? Let's use a 5% confidence level. okay, for this, or sorry, 95% confidence level. That'll be our default. Pooled, no, we do not want this pooled. Pooled would mean that it was paired data. It's not paired data. Pooled, no, we're not pooling our data. Okay, and we want to hit calculate. And this should come out with, okay, negative at the top there, negative, okay, this is my interval, negative 14.29 to 6.5, sorry, 6.353. Okay, so that's my confidence interval, right? That's my confidence interval. Okay, so what's our conclusion? What's our conclusion? Okay, notice that the calculator did calculate the degrees of freedom for me as 56.247. That's this hellacious calculation up here. Okay, that's that guy there. The calculator does that for me. It also calculates the T star for me based on that number of degrees of freedom, which you couldn't even do if you didn't have the calculator. Okay. Okay, and then it calculates everything else. Okay, well, everything else we gave it. Okay, but it gives us our interval. Now, what does this mean? What does this interval mean? This means that we are 95% certain or 95% confident that the true difference is between negative 14.29 and 6.353. Now, what does that mean? What does that mean? I really wanted to know, are the groups different or are they not different? Well, does my confidence interval contain 0? Does my confidence interval contain 0? Well, it goes from a negative number to a positive number, right? So if it goes from a negative number to a positive number, wouldn't it have to go through 0? This is an interval. This is like a line, a number line. Struggling to try to figure what that was. This is like a number line. We're going from negative 14 all the way to 6. Well, to go from negative 14 all the way to 6, wouldn't we have to go through 0? So couldn't 0 be a part of that? Yes. That means it is highly probable that there was no difference. There was no difference. Was there a difference? Could be, but we're 95% certain that there probably wasn't a difference. And so we could say that that no difference let me how would I want to phrase this? That no difference is probable. Okay, it's probable that there's no difference there. Okay, that it really didn't make a difference on whether or not group 1 was babysat or group 2 was not. There really wasn't a significant difference in the averages of the test scores. Okay, and we only know that because 0 was a part of our interval. Okay. Okay, let's go to example 5 now. Okay, let's skip down. We did all the other ones for proportions. Let's do example 5. Here we're just setting up the hypothesis for the hypothesis testing. Or I guess I should say hypotheses. Okay, we're just setting up the hypotheses for the hypothesis testing. So let's see what we can do here. 2 researchers investigated, oh man, it's the same freaking example. Okay, Two researchers invested the reliability of test assessment. One group consisted of 30 students and the other 32 students. Two samples were taken independently and not paired. Okay, we wish to see if there is a difference in the scores between the two groups. So what would be my null hypothesis? My null hypothesis is that there's no difference. There's no difference. Well, what does that look like? Mu1 minus mu2, that's the difference in the means, right, is equal to 0. Okay, or I could write this as mu1 equals mu2. Okay, mu1 is equal to mu2. Okay, what would be the alternative? Well, that would be that there was a difference. Mu1 minus mu2 is not equal to 0, or if I toss the mu2 to the other side, mu1 is not equal to mu2. That would be my alternative. Okay. Okay, what about here? We wish to see if the proctored test is lower. The proctored test is lower. Okay, so what would be the proctored test being lower than the unproctored test? Well, we're calling mu1. It would be the same thing for my null. My null doesn't change. Mu1 is the proctored test. Mu2 is the unproctored. So mu1 minus mu2, the difference of the two exams, the two means is 0. Means there's no difference. No difference. Okay, or we could rewrite that as mu1 is equal to mu2. Okay, what about if it's lower? Well, mu1 minus mu2 would be what? Okay, we have to think about this. Maybe it's easier to think of it in terms of numbers. If this is 70 and this is 74, what would happen if I subtracted a small number? Sorry, if I subtracted a big number from a small number. If I subtract a big number from a small number, wouldn't I get a negative number? If I take, yeah, thank you, Daniel. It would be negative. You're absolutely correct. It would be a negative number. And negative numbers, are they bigger than 0 or less than 0? Are negatives bigger than 0 or less than 0? Oh, they're less than 0. So we would write our alternative as mu1 minus mu2 is less than 0. Okay, or if we tossed mu2 to the other side, it becomes positive, and we say that mu1 is less than mu2, which makes sense, right? Mu1 is less than mu2. Okay, the proctored exam is less than the non-proctored. Okay, those would be my nulls. Oh, one thing I forgot to do before, so that's how we write our hypotheses. One thing I forgot to do before was to show how we got this guy in StatCrunch. So let me do that real quick. Okay, so StatCrunch. I do like this better. Okay, move this over a little bit if I can. Okay, so let's go to StatCrunch real quick. Why do I have two of these open? Oh, this one. Which one do I want to go? Online? No. Cancel. There we go. Cancel. Okay. So now let's go to StatCrunch. So let's see how we do a 2-sample T interval in StatCrunch. A 2-sample T interval. Okay, this is taking forever to load. It always does. StatCrunch is not too fast. Dun, 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 dun. Any day now. Okay, open StatCrunch. Okay, so we're gonna go to stat, and what do we want? T-stats, and we want to sample, and then with summary. So T-stats to sample with summary. And it says, okay, what's your sample mean? Well, what was our sample mean? Our sample mean was 70, group 1. This was 70.29. Okay, what was our sample standard deviation? It was 22.09. Okay, what was our sample size? It was 30. Okay, for the second group, it was 74.26. That was our sample mean. Our sample standard deviation was 1815. Oh, that was a good year. I'm just kidding. I don't know what happened in 1815. I wasn't around. Okay, sample size is 32. Okay, do we want to pool our variances? No. Okay. Do we want a hypothesis test or a confidence interval? We want a confidence interval. Okay, so I'm going to click on confidence interval here. And what do we want? We want a 95% confidence interval. Yes. And then I'm going to hit compute. And it's going to tell me what my lower and upper limit are. My lower limit was negative 14.29. 3, and my upper limit was 6.352. So that's how you do that on StatCrunch. Okay. Okay, same results as before. Now, is 0, we really only care, is 0 a part of this interval? Yes, then there's no significant difference. No significant difference. Okay, between the two populations. Okay. Let's move on to example 6. Sample 6. Okay. Which is the same example. What did they do? They recycled the same example 1, 2, 3 times. Okay, that's fine. We're gonna get really good at this one example. Okay, 2 researchers, example 6. Okay, 2 researchers investigated the reliability of. I'm not gonna read this whole thing again. Okay, the 2 samples were taken independently, right here, and not paired or matched. Assume the conditions for inference procedure are met. Okay, we're assuming that they're met. Use a 0.01. So alpha in this case is 0.01 significance level. So we want to be really certain. We want to be 99% certain that there's no difference here. Okay, let's see how we do. Okay, so what is my null hypothesis? Well, that's mu1 is equal to mu2. Okay. No, don't mix that up with the Pokemon. Okay, it's the Pokemon Mewtwo. So that's a little Pokemon joke. Okay, so just roll with it. Okay. Okay, so mu1 is equal to mu2. Okay, and then mu1, we want to know what? We want to know if the non-proctored group is significantly higher The non-proctor group is significant. Well, which is the non-proctor group? That's group 2, right? So we could write this as is mu2 greater than mu1. The only problem is that I want to compare apples to apples. So I actually have to translate this into mu1 is less than mu2, if that makes sense. Okay, so they're saying is group 2 bigger than group 1? Well, isn't that the same as saying is group 1 less than group 2? And yes, it is. Okay, it is the same. It's the same thing. It's just trust me on that. It's the same thing. Okay, so that's part 1. Okay, what are we going to use here as our test? Well, we're going to do a hypothesis test. We're doing a hypothesis test on this. Okay, not a confidence interval. And how do we know? We just want to know, is it significantly higher? We don't want to know the number or the value. We just want to know, is it higher or is it not higher? So we need a p-value. So we're going to say number 2 here is a 2-sample t-test. Okay, 2-sample t-test. That's the test we're using. Number 3, are all of the conditions for inference met? Yes, all the conditions are met. So I'm just going to say met. Check. Okay, what about number 4? What's number 4? Number 4 is actually compute the t-statistic and the p-value. So we're going to let the calculator do that because it would be a nightmare trying to do that computation by hand. Okay, so we're going to go stat, and we're going to go over to test. And what do we want now? We want number 4. Okay, this is number 4 on the calculator. Number 4 on calc. Okay, so number 4 is 2-sample t-test. 2-sample t-test. Okay. And you should have access to a calculator like this. Okay. If you're running, your own personal computer, okay, you can download the software for free, and that's on the Canvas page. Okay, so just keep that in mind. You can download that calculator for free. Okay. Well, not that calculator. It's slightly different, but make sure you have access. If you want free access to the calculator, so you have it for the exam, which you will need access to some way to calculate hypothesis tests, okay, and confidence intervals for the exam. Okay, you're going to need to be able to calculate these things. So I posted here free TI calculator on the computer. I posted that as an announcement, and you just go to TI Calc, and this will give you 6 months free. Okay, so 6 months free license for their calculator software. What does their calculator software look like? Well, let's go to TI Connect here. It's this one. It's the TI Smart View, and theirs looks like this. If I can get it to run, maybe. Okay, I'll share it real quick. Okay, so all you do is, sign up. And then they send you a license that's good for 6 months. Okay, is it working? Is it it's thinking about it. I guess I need to get a faster computer. I don't know. I'm debating it. If I have to teach on a computer in the fall, I'll probably get a faster one. But whatever. This is good for the next few weeks. And here it is. Here's their calculator. Okay. If I wanted to do a confidence interval on this, right? Here's what it looks like. Test, right? And what are we going to go to? See, this one's a little bit sexier than the one that I've been working with. But this one takes up the entire screen. So I don't want to work with this one. Okay, but this is nice if you're just, okay. There's different skins for this as well and different setups. So, so yeah. So where's the emulator view? View, let's see, hide large display. There's the small display. Let's view this, hide key press history, and then hide view, boom. Okay, I wonder if I can minimize this thing to make it even nicer. I don't know. It's kind of hard to see the bottom row there, but at any rate. Yeah, so I just hit enter. Okay, everyone's screen is blurry. Is everyone's screen? Maybe it is because the internet is slow for this thing. I'll get rid of this thing. Okay, it was just to show you how to get it on yours. Okay, yeah, yes, okay. I mean, no, I'll get rid of this. It's not good. Let's get rid of that guy. Oh. Go back to what was working. Okay. It's just Zoom takes up so much RAM that it's crazy. It's almost like you need 16 gigs of RAM just to run Zoom correctly. And you can't open a whole lot of applications. Otherwise, everything goes blurry, like when you're trying to stream like a 4K resolution YouTube video, everything's blurry because the processor can't keep up. Right? Okay. Is this better? Is that better, or is it still worse? The screen teacher, please. The screen teacher, please. Could you translate that for me? What does that mean?
It's still blurry.
The screen is still blurry?
Yeah.
Okay. It's still blurry. Okay. Okay. I'm gonna get rid of StatCrunch then. Just say goodbye to StatCrunch. Goodbye. Goodbye. Goodbye to StatCrunch. And let's see. And then goodbye to this. And goodbye to you, sir. And goodbye to you. How's that? We got rid of everything. And goodbye to you. No, not goodbye to you. Oh, stop the share. Okay. And okay. Unable to read it. Okay, that's good to know. Okay, let's try to share it again. Okay. Let me go check something out. 1 second. Is that better, or is it worse?
It was better when you initially did it, but now it got worse. And the interesting thing is that your picture is crystal clear. It's just the image that you're sharing that is unreadable.
Okay, so my picture
it's
so
crystal clear.
Okay, so it's the sharing aspect of it.
When you initially shared it, it was perfect, but then when you got up and whatever you did made it worse.
Okay. Interesting. Let me change my internet connection real quick. I have 2 of them, so I can change to a more secure connection. Maybe. Now my audio just went out. Closed system resources. Wonderful. So now, okay, can you hear me? Can you hear me? Yes or no? Okay, so I tried to change it to a stronger connection. How is that? Is that still bad or is
Your
that
screen is clear now.
it's clear now? Yay. Yeah, I switched over to a stronger connection. Okay. Okay, okay, sounds good. Go away. Okay, so yeah, so I think it just it slowed everything down when I tried to do the sharing of too much stuff. Okay, so we want to go to number 4 here, 2 sample t-test. And we want to hit enter. Okay, what's the data? Well, it's already in there. The data is already in there from the confidence interval that I did. Okay, so yes, yes, yes. Okay, now the only thing that we have to do is we have to make sure that our alternative hypothesis is correct. So what are we doing? We're comparing mu1 to mu2, right? And we're saying is mu1 less than mu2? Okay, so that's we're going to hit enter, mu1 less than mu2, and then we're going to hit calculate. And this should give me my t value and my p value. Okay, let me make sure that I plug this in correctly. Okay, mu1 less than mu2, that's correct. Okay, and let's make sure everything's correct. 70.29 is correct. 22.09, that's correct. 18 point, yep, that's correct. What about N1? N1 is 30, yep. And N2 is 32, yeah. Okay, so what's T? My T score is 0.770, I'm gonna say. That's my T score. And what would be my P value? My P value is 0.222. Okay, now, what's my conclusion here? What's my conclusion here? Well, the P value is much, much bigger.
But isn't it a negative t value?
Yeah, thank you. It is negative. Okay, the P value is much, much bigger than my significance level, right? So what does that tell me to do? When my P value is very large, that tells me that I failed to reject the hypothesis. This tells me that we are 99% certain that what? That there is no difference in the average scores. Okay, that we're 99% certain that there is no difference in the average scores. Okay, there is no significant evidence that the proctored group, okay, did any different than the non-proctored group. Okay. Okay, makes sense? Okay, let's go to the next one here. The next one Okay. And again, if you wanted to use StatCrunch, you can. Instead of clicking on confidence interval, you would just click on hypothesis test. Boom, that's it. That's the only difference. Okay. So it's super simple. It's the exact same thing that we did before. Okay, what about example 7 here? It says weighted alpha is a measure of risk-adjusted performance of stocks over a period of a year. A high positive weighted alpha signifies a stock whose price has risen, while a small positive weighted alpha indicates an unchanged stock price during the time period. Weighted alpha is used to identify companies with strong upward or downward trends. The weighted alpha for top 30 stocks of banks in the Northeast and in the West, as identified by NASDAQ on May 24, 2013, is listed in the table below. Is there sufficient evidence of a difference in the weighted alpha between the two regions? So we have to do a hypothesis test to see if there is a difference, a significant difference in the weighted alphas, which are these values here that they're giving me. It looks like there's 30 values for each. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's 30 values for each. Okay, so let's do our hypothesis test. First is to write the null and the alternative. So what's the null going to be? The null is that mu1 is equal to mu2. That's the null. That there is no difference in the averages. Okay. What about the alternative? What's the alternative? The alternative is that there is a difference. Mu1 is not equal to mu2. That's the alternative. What's the test that I'm going to want to run on the calculator? Well, let's go to stat. Let's arrow over to tests. And I believe that this is the 2 sample t-test, number 4. Okay, so that's 2 sample t-test. Why 2 samples? Because we have 2 sets of data here, the Northeast and the West. The Northeast and the West data. We're going to compare the 2. Okay, so let's see if our criteria is met. Is our criteria met? Number 3, is it independent? Sure. Is it random? Sure. Are both of them N1 and N2 greater than 30? Greater than or equal to 30? Yeah, they are equal to 30. So there you go. Satisfied. Yay. Number 4, we have to calculate the t-score and the p-value. Okay, so what's the t-score and the p-value? Well, we have 60 pieces of data here. So how are we going to calculate the t-score and the p-value on 60 pieces of data? Well, guess what? We have to input the 60 pieces of data into our calculator. That's how we do this. Well, how do we input these 60 pieces of data into our calculator? Well, we go to stat and we edit our lists. I'm going to go arrow up and I'm going to hit clear. And then I'm going to let L1 be the Northeast data. So I have to enter this data. Feel free to enter it right along with me in your calculator. 94.2, 75.2, 69.6, 52, 48, okay, 41.9, 36.4, 33.4, 31.5, 27.6, 77.3, 71.9, 67.5, 50.6, where are we at? 46.2, 38.4, 35.2, 33, 28.7, 26.5, sorry, 70, stop, behave. There we go. Okay. Where were we? 26.5, 76.3, 71.7, 56.3, 48.7, 43.2, 37.6. Whoa, what happened? Let's go back to edit. Okay, where did I leave off? We're done with my first row, second row, we got to 24, okay. Okay, so we got to 56.3, okay, 48.7. Okay, and then 43.2, and then 37.6, and 33.7, 31.8, 28.5, and 26. Boom. Okay. Okay. Now, if I was really wanting to make sure that this is completely accurate, I would go over all of my numbers one more time. Okay. And you should do that. If you're doing this on the homework, you should absolutely go through your list one more time to make sure that you didn't input anything, incorrectly. I'm pretty certain that we're good. I want to just make sure that I have 30 numbers. Okay, and I do. So the 30th one was 26, which is good. Okay, I'm going to go to L2 now because I don't want to waste so much time entering these 60 numbers. It is time consuming and kind of a pain. Okay, 70.6, 65.2. So you can see why it's a lot nicer when they give you the summary data already done for you. They calculated all the means and standard deviations for you. It's a lot nicer. 45.5, 37, 33, 29.6, 23.7, 22.6. At least I have a keyboard that I can do this on. 116.1, 70.6. Oops. 70.6. Okay, 58.2, 51.5, or sorry, 51.2. Okay, 43.2, 36, 31.4, 28.7, 23.5, 23.5. Go for 23.5. And the last one in that row is 21.6. Okay, last row, 78.2, 68.2, 55.6, 50.3, 39, 34.1, 31, 25.3, and 23.4, and 21, and hopefully, or sorry, 21.5. Okay, and hopefully they match up. They do. I got 30 of each in there. Good, yay. Now we're gonna do our hypothesis test on the two samples. We're gonna go to stacked. Yes?
There was a mistake that you entered in on the 50.3.
50.3? Oh, okay, thank you. Thank you. Let's go back to my lists. Okay, well that would have been like the 23rd entry or so. Ah, thank you. 50.3. Enter. Perfect. Okay. 39, 34.1, 31, 25.3, 30. Okay. It's all good. Okay. Okay. So go to stat, test, number 4, 2 sample t-test, 2 samples. And here we're going to want to use the data that we entered. The data. What's L1? It's list 1. What's mu1? We're going to get from list 2. What are we testing? We're going to test whether or not they are equal to each other. So we're going to hit enter on the not equals, and then we're going to go calculate. Okay, and we would hit calculate here. Okay, T, okay, T is coming out to, okay, about 0.145, okay, and a p-value of 0.879. Oops, 0.8849, sorry, 0.885. Okay, p-value is huge. Okay, it's very big. Okay, so what does that p-value tell me? That p-value tells me that there is there's definitely a difference here. Okay, that this is bigger than 0.05. Okay, or sorry, there is definitely not a difference, is what I should say. There is definitely not a difference because the p-value is bigger than the significance level. Remember that it's the difference of the two that we're looking at. Okay, and this p-value is pretty big. It's over here, actually. Okay, it's this whole thing here is the p-value, which is, it just tells me that, yeah, there's no real significant difference. Now, because the p-value is so big, I may want to, instead of looking at the lower tail, I may want to look at the upper tail, which is 1 minus the p-value. So let's look at that. Let's look at 1 minus the p-value, just to make sure that we're not on the wrong side of this thing. Okay, so what's 1 minus my p-value? 1 minus p. No, I want lowercase p. I'm going to go to my variables, and I'm going to go, oops, what the heck. I'm going to go to my variables, and I'm going to pull my statistics variable. I want lowercase p. Is lowercase p going to be there? Yes, it's right there. So I do 1 minus lowercase p. And it tells me that it's 0.111. This is 0.115, which is still bigger than 0.05. So either tail that I use, no matter which tail I use here, okay, whether it's the bigger one or the smaller one, I'm still getting it to be bigger than 0.05. So we accept or fail to reject the null. Okay, so what's our conclusion? Okay, our conclusion here is that since p is greater than 0.05, okay, we fail to reject the null. Therefore, there is insufficient evidence okay. There is insufficient evidence to show any difference between the two groups. Okay, so that's my conclusion. Okay. Okay, so we failed to reject, which means that the two groups are basically very similar. Okay. in their means. And I wonder if I could go back to my stat and and it's going to calculate the means and the standard deviation. Let's see what, let's go back to this. It should have calculated all of that for me. Oh my gosh. Okay, so why does it keep doing this? Stop. Okay, hit calculate. Boom. Okay, so the average for the first group, this is kind of interesting. The average for the first group was 46.9. 46.96. Okay, the average for the second group was 46.05. That was the average for the second group. That's kind of cool. Okay. The standard deviation for the first group was 20. Why is it not writing? S of x is equal to 20.5 for the first group, and S of x for the second group was 27. So yeah, these groups are almost identical. Okay, and what was N1? Well, N1 was 30. N is equal to 30 here. And N2 was the same, N is equal to 30. So the same number of items in the groups, extremely similar means. Okay, I mean, you can't get much closer than that. Okay, extremely similar means and even pretty similar standard deviations. So the two groups behave very similarly, which is why we got such a high p-value. Okay, extremely similarly. Okay. 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 Paired. What does it mean when groups are paired? Okay. Remember, this is like if we have siblings or if we have spouses.
I have one question on the previous one we just did, example 7. I put all the figures in StatCrunch, but what would I go and do? Because I tried to do what it said before, to do T-stats 2 samples.
Yeah, and you do with data, not summary.
I did it with data.
Okay.
Then I got stuck.
And what did it ask for? You put it in StatCrunch.
Hold on, because I have to go to a different screen. It says 2 sample t values and it puts the variables in, and I put variable 1, and then it says where.
You have to put variable 1 and variable 2.
I did variable 2, but do we do anything where it says where?
No.
Okay, and then what was the confidence value?
It's not, there is no confidence value. It's not a confidence interval, it's a hypothesis test.
So then where should,
can you see my
okay,
screen?
yes, where it says hypothesis. Okay, so what numbers go in there then? The ones that we have?
What do you mean? There's no numbers. You're pulling the data from the spreadsheet.
Mm-hmm. Okay, so all you have to do then is compute?
Yeah, just hit compute.
Okay, got it. Thank you.
Okay, sounds good. Okay. Okay, what happens if they are paired? If we have pairings, right? So say that we have husband and wife, right? Husband and wife. Okay, and we'll say that this is just hypothetically, okay, husband, wife, and this is maybe minutes that they exercise. Maybe husband does 15 minutes and the wife does 30. The husband does 70 minutes and the wife does 45. Okay, maybe the husband does 5 minutes and the wife does 15 minutes. Okay, now would I want to just average all the husbands together and average all the wives together and compare them? Well, no. And here's the reason why. Because maybe you have a husband and wife that are very athletic, right? And maybe you have a husband and wife that all they do is sit at home and watch Netflix. Their behavior is influencing each other. So we call this paired data. This is paired data. So the husband, every row here is paired. Husband gets paired with wife. Husband gets paired with wife. Husband gets paired with wife. And so instead of taking an aggregate of all the husbands and aggregate of all the wives, what we do is we take two pieces of data and we turn it into one by taking the differences of each pair, each couple. I want to find the difference of each couple. So the difference in the first one would be negative 15. That would be the difference. If I subtracted 15 minus 30, I would get negative 15. Okay, for the differences. Okay, negative 15. So negative 15 for the first one. What about the second one? That would be what? 25? Okay, is the difference there in the husband wife. And then here, 5 and 15, that's negative 10. So I run with just, I make it a one sample t-test, okay, or which is just a t-test. I would do a t-test on this. It's one sample, and what would I use as my data? I would use the differences as my data because I'm pairing them together, okay? The data is paired, like before and after you take an exam. Twins, siblings, left and right, okay? Husband and wife, these are all things that we could pair one to another, okay? You know, even in an experiment, we have paired data, right? We say, oh, this is what the person was before they took the drug, and this is how the person reacted. We don't compare Jim's reaction to Ken's reaction. We compare Jim's reaction to Jim's reaction. We do before and after. We take Jim before and we compare him to Jim after. We don't take Jim before and compare him to Ken after. That would not be right. Okay, because we don't know what Ken was like before. Maybe Ken was completely different than Jim, right? So whatever we're comparing, we have to compare apples to apples. We can't compare Jims to Kens. This is not going to work. Okay, or Kens to Ryus. It just doesn't work. Okay. Okay. So if we pair the data, we want to do a hypothesis test here. And it says the listed below are the systolic blood pressure measurements in milligrams of mercury taken from the right and left arms of the same woman. Okay. The same woman? Oh, okay. Same woman, I guess. Okay. Is there a difference in the arms? Okay. Is there of the same? I think this should say same women. Women. Because this should be woman 1, woman 2, woman 3. Okay. This is woman 1. Unless they were just at different times in the day that they took these of the same woman. I'm just going to have them be different women. Okay. But would you want to compare women, I can't say it. Women ones, that's really hard to say. Do you want to compare women, the first woman, her left arm to the second woman's right arm? Would you want to cross the streams? No, you don't want to cross the streams. Don't do that. It's bad. Okay. So what do we want to do? We want to compare one woman's right arm to one woman's left arm, the same woman. Same woman, same woman, same woman, same woman. Or if these were times in which the same woman was tested, then we want to test time 1 and time 2, time 3, time 4, time 5. We want to compare what is the same here. So what are we going to actually compare? Well, we're going to compare the difference between the two. Okay? If it was a hypothesis test, it would still be mu1 okay, mu1 minus mu2, okay, but in this case, that's mu3. Okay, and in order to know if there's a difference between mu1 and mu2, we want to know, is mu3 equal to 0? Is the difference equal to 0? That's how we're going to test this hypothesis. Okay, so what are the differences here? Let's calculate the differences. 15 minus 2, that's 13. 99 minus 101, negative 2. 110 minus 90, or 112 minus 94, that's 18. 97 minus 98, negative 1. And 120 minus 99 is 21. Okay. And I want to know, is there a significant difference? This is my difference data. Difference data. That's my difference data. Okay. So we don't use mu1, mu2. We say there is mu3, which is the difference. This is my difference data. Is the difference equal to 0? Is the difference equal to 0? What's the alternative? The alternative, okay, is what? We want to know is use a 0.01 significance level test for a difference. Is there a difference? Well, we want to say no, the difference was not equal to 0. Okay, that there was a significant difference. Now, what is the difference? What are we looking for? We're looking for the averages. Okay, so we would say that mu3, okay, is equal to, okay, mu3, it's not mu1 or mu2, this is mu of the difference. Maybe we could write that mu sub d for difference. The average of the difference is equal to 0. That means there was no difference between the left and the right arms of these ladies. Okay, and mu difference, there was a difference. Okay, that the difference was not 0. Okay, but there was a significant difference. Okay, that is bigger than 0 or less than 0. Okay, so that's number 1. 2, let's do a one sample t-test, which is just called a t-test. Why is it one sample? Because we've already calculated the differences. We've already done that ahead of time because it's paired data. Now, I could let the calculator do this for me. Okay, I could let the calculator do this for me. And this is how I would do it if I wanted the calculator to do this for me. Okay, this is what I would do. I would go to stats. Okay, second stats. I would turn the calculator on first. That would help. Okay, I would go to stats and I would go to edit. Okay, now I want to edit my list 1 and my list 2. I'm going to hit clear. And I'm going to hit clear. Oops. Hit clear. Clear and enter. There we go. Now, what's list 1? Let's let the left arms of these ladies be list 1. That's the left arm. That's the left arm is 115. Okay, 99. I mean, we have data here. We have to use the data given. 112, 97, and 120. So list 1 is going to be my left arm. I'm going to make a notation of that. That's L1. Okay. What's the right arm going to be? Well, the right arm is going to be list 2. So let's go over to list 2. List 2 is going to be the right arm, 102. Because I want to know, is there any significant difference between the arms? 102. Okay, 99, 101, 94, 98, and 99. Okay, 99. Okay, now, I'm lazy. I don't want to subtract all this, especially if I had a much longer list. If this was a list of 30 pieces of data, okay, I would just pray and give up. No, I'm just kidding. I would list them all out. I would check my list, but I don't want to sit there and go through and subtract the difference for all of these. So I'm actually going to let the calculator do that grunt work for me. I'm going to arrow up until it highlights list 3. And then I'm going to tell list 3 what I want it to be. What do I want list 3 to be? Well, I want it to be L1 minus L2. I want list 1 minus list 2. So how do I do that? Well, I go second and then 1, second 1. And that says, oh, you want list 1? Yeah, I do. I do want list 1. Thank you very much. And then I subtract from list 1 what? What am I going to subtract from list 1? Second 2 will get me list 2. And what does that tell me? It says that list 3 should be equal to list 1 minus list 2. Okay, so this guy was list 2. The difference data is list 1 minus list 2, which we're calling list 3. And if I just hit enter here, boom, look at that. It magically gives me list 3. Nice. I didn't have to go through calculating it, all the differences. It calculated it for me.
Professor, when I go to do that on my calculator, it just keeps saying error.
Okay.
If I do L1 minus L2.
Right. Make sure that the same number of items are in list 1 as list 2.
Okay.
Also, make sure you didn't use the negative sign. You use the subtraction symbol.
Yes. And then just enter?
Yes, and then just enter.
Yeah, it keeps saying error data type.
Okay, did you arrow up for list 3? Is list 3 highlighted?
Let me.
You have to arrow all the way up to list 3, like you were trying to clear the list.
Okay, there we go. Thank you.
Yeah, that's what you did. Because it's wanting a number. If you just try to put it in as a value, it's wanting a number, not a formula.
Okay.
You
Thank
have to designate that it is for the entire list 3 that you want this to be done. Okay, so now what are we going to do? Well, we're going to go and we're going to do a hypothesis test. That's what we need to do on this thing. We're going to go 3. Is this met? No, really, it's not met. The criteria is not met. Not met. Why is it not met? Because we only have 10 pieces of data. Okay, we don't care. Not met, but we will roll with it. Happy face emoji. Okay, so we're going to roll with it anyway. Okay, we'll assume that these are averages of much bigger data sets. Okay, maybe there's 30 pieces of data that gets me the average of 115. So we're going to say that maybe there is more than 5 pieces of data for each of these, but that's okay. Let's get the p-value for this. So we can. Okay. Okay. So I'm going to go over to test, and then I'm going to do t-test. Okay, and I'm going to go data for my t-test. Okay, data for my t-test. Okay, and it says what am I doing here? This should be correct. Oh, and saying, yeah, what do you want it to compare against? What do we want to compare against? Any ideas? What is the hypothesis test comparing against? What's the value? What's the average value that we're comparing against? What's mu sub 0? Any guesses? Well, what's our null hypothesis say? We want the difference to be equal to 0. We want the difference to be equal to 0. Mu sub d is equal 0. So what is our average? Well, our average difference should be 0 for our null. That means there's no difference. So we're going to put a 0 in there. This only gives me a place to put in one list. Well, that should make sense because we only need one list. Which list do we want to put in here? How about L3? That's the list that we calculated the differences. We had to pair the difference, and so we had to do all the differences first in order to get L3, and so L3 is what I want. So I'm just going to go second 3, and that's going to populate 3 here. The frequency is 1, that's fine. You can just leave that. It tells me how many times I'm going to use these lists. I'm just going to use them once. And then mu is the difference is not equal. That's the alternative, not equal. And then I'm going to hit calculate. And this tells me that I have a t-score, okay, a t-score of 2.046 and a p-value of 0.110, which is greater than my significance level, which is greater than 0.01. And so what do? Okay, I accept that there is no difference, just like before. So we accept that there is no difference here. Okay, so there is no significant difference in the blood pressure between the left and right arms. Okay, so that's my conclusion. Hopefully that makes sense. Okay, let's go to 11.5.
What the?
Oh, that's spicy reaction. Let's mute everybody. Boom. Okay. Let's go to 11.5. Okay, let's do three last examples, and then.
You mean 10.5, the 2-sample practice?
Yeah, sorry, 10.5. What did I say? 3.5?
Said 11.5.
11.5. Okay, yeah. Yeah. Okay, yeah, 10.5. I want 10.5. Okay, the 2-sample practice. We're going to do 2-sample practice. Boom. Looks like this. Two samples, and it's practicing. Practice our two samples. What seriously doesn't want to go? Oh, I got to shrink it. Shrink. There we go. Nice. Let's bring you up, sir. Okay, let's go over our 2-sample practice here. Okay, a professor at a large community college wanted to determine whether there was a significant difference in the final exam scores between the students who took his statistics online class and the students who took his face-to-face statistics class. He believed the final exam scores for the online class would be lower than the face-to-face. Okay. Was there sufficient evidence to show the professor was correct? 30 final exam scores from each group are provided in StatCrunch group. I don't have access to this, so we're just going to set up the problem. We're going to do set up only on this first one. Set up only. Okay, that means going through steps 1, 2, and 3 only. Okay, move step 2 down. Step 2 and 3. Okay, we're just going to do the setup only. Okay, use alpha of 0.05. Okay, so how would I do HO? and HA. What would be my null and what would be my alternative in this case? Okay, I have students who are in a face-to-face class and I have students in an online class, and I want to compare the two means. Okay, is this going to be paired data? No, it's not paired data because not any one student is in both classes. Okay, they're different students in different classes. One just happens to be online and one just happens to be, there's no overlap. There's no crossover between individuals here. So this is just a regular two sample t-test. Okay, t-test. And so it's going to be mu1 is equal to mu2. That's my null. And we want to know if there's any difference, right? Is there any difference? Where does that say? We believe the final, oh no, no, not difference. It's, we believe that the final exam scores would be lower, okay, than that in the face-to-face. So if we let mu1 be the online class, then we would expect that the online class would actually be lower, okay? So let group 1 be online, let group 1 be the online class, and let group 2 be the face-to-face. Okay, group 2 be face-to-face class. Okay. So mu1 equals mu2 means there's no difference between the classes and their final exam scores. And mu1 is less than mu2 is that that the online class did worse. That would be the alternative here. The alternative, this is the claim. Okay, this is what he's claiming. He's claiming that they're going to do worse online. Okay, what would be 3? Here, 3 would be I would have to test whether or not it's random assignment, okay, if it's independent, okay, and if each class was bigger than 30 or not. Is each class is N1 bigger than 30 and N2 bigger than 30, okay? So I would have to test that. And then I could run my stats with the data provided. Okay, we don't have the data provided, so okay, we're only going to do the setup on that one only. However, for number 2, we do have the data provided. Okay, for number 2, a research study was conducted about gender differences in vaping. Right? The researcher believed that the proportion of girls, so this is a proportion, the proportion of girls involved in vaping is less than the proportion of boys involved. Okay, so let's just stop there for right now. Let's write our hypothesis. Okay, our null and our alternative. What would the null be? The null would be that the proportion of boys vaping is the same as the proportion of girls vaping. Proportion of boys vaping is the same as the proportion of girls. Okay, what would be the alternative? The alternative is that girls is less than boys. Girls is less than boys. So girls is less than boys. That's the same as saying that the boys are more than the girls. Okay, so that's the null and the alternative. What type of test is this going to be? Well, I have 2 categories, right? So this is a 2 prop. And when we use proportions, do we use Z's or T's? Yeah, we use Z's. So 2 prop Z test. That's the test here that we're going to use. Number 3, is this independent, random, and do I have a large enough sample size? Oops. Independent, that's a check mark, by the way. Check. That's a check mark. Okay, random, and is the sample size large enough? Well, is N1 times P1, which is X1, remember that's Okay, n times p is equal to x. Is x1 greater than or equal to 30? Well, yeah, there's 183. So x1 is the number of boys vaping, okay, in my first, in the group of men, or sorry, in the group of boys. So the number of boys that are vaping is 183. So 183 is greater than or equal to 30, so that checks. What about the second group, which is the females, N2, P2? How many girls are vaping there? Well, that's 153, greater than or equal to 30. Yes, that checks as well. So 1, 2, and 3 check. What about 4? Let's run the values here. Okay, so this is going to be a 2-prop z-test with summary. Okay, this is summary statistics. Okay, so we're going to say stat test. This is a 2-prop z-test. So that's number 6 on the calculator. 2-prop z-test. Okay, on StatCrunch you just do prop and then prop and then something and then summary. What is it? Prop and then I forget what it is. Prop and then something and then summary. Prop and then it's 2 sample. Prop and then 2 sample and then summary. Okay. So here x1, what's x1? X1 is 183 for the boys. Out of how many total boys? 2, 2, 3, 1. Okay, what about x2? That's 153 girls. Out of, okay, 2169. 2169 girls. And what do I want to know? I want to know, is x1 less than x2, right? Is the proportion p1 less than p2? Is the proportion less than p2? So I'm gonna hit enter on less than, and then I'm gonna calculate this. Okay, and I'm gonna say, okay. Okay, p1 is less than p2. So what's the z-score? The z-score is 1.43. Okay. Okay. You know what? I screwed up. My bad. This is wrong. What did I do? What did I do wrong here? The inequality was reversed. So it's the boys is greater than the girls. The boys is greater than the girls. So let me do this again. Okay. So 2-prop z-test. Okay. It's all the same. And we want greater than, not less than. Greater than, and then hit calculate. There we go. That's much better. This is 1.43. I'll put is my z-score. 1.434. 34. And then what's the p-value? The p-value is 0.076, I'll say. And that is greater than 0.05, which is our default significance level. Okay, so our default significance level is 0.05. And so what does that tell me? That tells me that what? That there was no significant difference. Okay, there was no significant difference here. Okay. So 5. So there is no significant difference in the vaping habits or in the proportion of individuals vaping with respect to gender. Okay, with respect to gender. Okay, so there's no significant difference between the genders when it comes to whether or not they do their vaping. Okay, so that's our conclusion. Okay, number 3. Use the following answer to use the following information to answer the next 5 exercises. I don't need 5 exercises. I just need this one exercise. Okay, a doctor wants to know if blood pressure medication is effective. 6 subjects have their blood pressures recorded. After 12 weeks on the medication, the same 6 subjects have their blood pressure recorded again. Okay, for this test, only systolic pressure was considered. Test blah, blah, blah. Okay, so is this going to be paired data, or is this just befores and afters? Do I care about pairing the data or not? Do I want to compare patient A before to patient A after, or do I really not care about which patient is which? Well, I want to compare apples to apples, and patient A could have abnormally high blood pressure before, and I do not want to compare that to somebody who has abnormally low blood pressure. Okay, so these are pretty high blood pressures, man. Okay, anyway, so I guess that's the whole point. So we want to pair the data. We want to say, hey, patient A, his blood pressure was 161. Patient B, that was before he took the medicine. After he took the medicine, it was 158. So what I really want to calculate are the differences here. The differences. For A, B, C, D, E, and F, what was the difference? If the difference is 0, no difference, then I know the medication was ineffective. If the difference is, okay, if there is a significant difference, then I know that the medication was effective. Okay, so this guy went down by how much? It went down by 3. This guy went down by 3 as well. This guy went up. That was not good. This guy went down by 2. This guy went up by 1. And this guy went down. Let me get rid of these circles. Okay, and this guy went down by 2, right? Down by 2. Okay, so this is the data that I want to work with. So once again, I'm just going to plug this data into my calculator. I'm going to hit stats. Okay, I'm not going to have the data, I'm not going to have the calculator calculate the differences for me this time. I already did that, so I don't need to have the calculator do that for me. Okay, if I wanted the calculator to do it for me, I could by just entering in the original data, but I'm too lazy for that, so I always want to do what's most efficient. So let's do 3, 3, -1, 2, -1, and 2. Okay, is that right? I should have 6 pieces of data. 1, 2, 3, 4, 5, 6. I do. Okay, so now I'm going to use that data to do a what? To do a t-test. Okay, I want to do a t-test. So let's so I want to do a t-test on the differences. T-test on just the differences. Okay, so let's set this up. What's our null? Our null is that mu is equal to 0. Okay, the difference is equal to 0. You could put mu d if you want. What's HA? Mu d. After 12 weeks, the test, we want to know if the blood pressure, okay, went down. Did the blood pressure go down? If the blood pressure went down, would that be a positive difference or a negative difference? If the blood pressure went down and I subtracted, if I subtracted and the blood pressure goes down, isn't that a positive amount? Isn't that a positive difference? Yes. So this would be greater than 0. The difference would be greater than 0 if the medication was working. Does that make sense? If I had a blood pressure of 200, which I'd be dead, and then it went down to 100, wouldn't that be a positive change? Wouldn't that be a difference that's positive? Yes, it would be. I'm glad you agree with me. It's really nice teaching remote because everybody agrees with me. Good. Okay, so mu d greater than or equal to 0. Okay. Okay. Okay, so what are we going to do here? We're going to go do a t-test, but a t-test on the difference, on the differences. Okay, number 3. Okay, we're going to assume that all conditions are met. Sure. Okay, number 4, we're going to actually run these values. Okay, so I'm going to go to stat, tests, and this is just a t-test. This is just a normal t-test. What's mu sub 0? Well, it's 0. Okay, what's the list that I want to pull from? I put everything in list 1. So that's second 1. And then I want to do, in this case, greater than. Do I want the difference? I want to see if the difference was positive. And I want to calculate. And this gives me a t-score of 1.75 and a p-value of 0.069. Okay, 0.069, or I'll just say 0.07. Okay, 0. Okay, that's greater than my significance level of 0.01. My significance level was 1%, which is 0.01. This is getting kind of messy. Okay, so 0.07 is greater than 0.01, which tells me to do what? It tells me that there was no significant difference. So no significant difference before and after. Oops. Before and after the medication. So obviously the medication did not work to lower the blood pressures. Okay, at least not significantly enough to say that it was good. Now, I don't know if you've been following the news at all lately, but they announced yesterday that there's a new drug that they think is being effective on the COVID virus, right? And so I was watching Dr. Fauci, who's kind of the guy that is the president's right-hand man on this thing. And he said yesterday, he said that I thought it was kind of interesting. He said that the p-value on the controlled experiment, which had 1,200 participants, n is equal to 1,200. Okay, and he gave the p-value on the controlled experiment for n equaling 1,200 patients in multiple countries. Okay, I forget what the drug is name. It's Revesquir or Quinn or I don't know. Revesquir. I'd have to look it up. Oh, Risedamir. Risedavir? I thought it was a V. Risedamir? Something like that? You could Google it. Like, yeah, something like that, right? So it seems to be a first step in this, but he stated the p-value, so I thought that was kind of cool. He said, you can Google it on YouTube too, and he's big. Okay, so let me see what is it Redesivir? No, Risedavir. I'm Googling Remdesivir. That's what it is. Remdesivir. right? So remdesivir, that's what it's called. Okay, so now I'm not here to get political or whatever. I could care less, okay, about the politics of the whole thing. Okay, but it says remdesivir, right? It went through, you know, phase 3 trial. Okay, first drug to found to block the coronavirus. It's a first step, but he gave the p-value, which was kind of cool. He said, you know, the p-value was like 0.01. Okay, and so I thought that was kind of cool. You know, here he's obviously knows his statistics, and he's saying, you know, in this controlled experiment where they had a control group which got a placebo, right? And this is exactly what you do with statistics. Placebo. This is why we talked about all this stuff. Okay, so we had a control group, okay, of maybe 600 individuals, and then we had the ones that got the remdesivir. Is that right? I don't know. Remdesivir. Okay, they got the control group, which is probably 600 people, and they saw a significant difference. And what was that significant difference was that, you know, the mean average time for these people to recover was 15 days, and it shortened the recovery period to 11 days. And so you're saying mu equal to 15, right? That would be your null hypothesis. And what would be your alternative hypothesis? It's mu is less than 15, right? And so given that the X bar was 11 days, right? Instead of 15, they're saying, oh, this p-value here was like 0.01, which is statistically significant. Statistically significant. So there's hypothesis testing right in the nightly news. It was right in the nightly news. He's like sitting there on the couch in the Oval Office, and he says, yeah, we did a hypothesis test on remdesivir, and it is showing statistically significant results that it is cutting the recovery period for the coronavirus down by a third. You know, it's instead it's 2/3 of the time for recovery instead of, you know, the whole time. So I thought that was kind of interesting. Here you have this, you know, liaison to the president for the CDC. I think he's the CDC liaison. I don't know what his title is, but he's touting, you know, exactly what we're doing in this class. He's speaking the language of statistics. I thought that was kind of cool myself. Hopefully you think that's kind of cool because you're like, oh yeah, I just learned this in my stats class, and here he's talking about the same thing. But anyway, whatever. I'll shut up now. So we are done with the examples. Okay, is nearly 8 o'clock. At this point, I will stick around for another half hour to field questions on homework if you have them. If you don't have any homework questions, you're feel free to go at this point. Okay, and I'll see you guys next week. Where's my stop sharing? Stop the insanity. Okay. Okay. And I'll start sharing. So hello. This is Buster, by the way. He keeps me company in quarantine. Hello. Hello. He's like 5 years old. He's my forever puppy. He will always be this size. Very small and very evil. He's actually a Sith Lord. I don't know if you guys know what that is, but look at those eyebrows. They're just evil. They're evil eyebrows. I don't think he really realizes exactly how evil he is, but he is. Come to the dark side. We have masks, respirators, and we have cookies. Wookiee cookies, actually. Wookiee cookies. Okay, so come to the dark side. Well, what breed is he? He's called a min pin. He's a miniature pincher, and the way that they get pinchers to be miniature is they mate them with chihuahuas. So he's half pincher and he's half chihuahua to try to get them to be miniature. So he's called a min pin. Min pin. MINPIN. Yeah. Thank you. I know. Oh, nice. Nice. Yeah. Yeah, they're really good dogs. They're really, really friendly, and they're just lap dogs. I don't know. They're like just want to sit in your lap and that's it, and just hang out. So really, really good temperament. The key is to flip them on their back. If you get a puppy, flip it on its back. If it squirms, don't get it. If it just lays there and is kind of content, then you get it. So that's what I did with him, and he's the chillest dog ever. So otherwise they're all yappy and high strung. You're like, no. So just flip it on its back. If it squirms, don't choose that one. That's my puppy advice. Yeah, you can use whatever you want, StatCrunch or TID4, or Jared uses these alternative websites. So that sounded kind of
None of them are working right now. I'm having like a lot of issues trying to do one problem. So
do you have an iPhone or do you have an Android?
I have an iPhone 11.
You have an iPhone. That kind of sucks.
I can't use it. I can't download a thing on my laptop because it's my work laptop, and I'm not authorized to download like things outside of the company scope. So I've been trying to, every time we do this lesson, I'll try to find some website, but this one has just been crazy to find something that can help me out.
Okay.
I tried StatCrunch, but they're asking me for $14.99 for like a bundle pack, and that
Right.
Yeah.
Well, how much does it cost to go to a movie? If you wanted to go see like the last Avengers movie, Endgame, right? Like how much is a movie ticket?
The theater by my house is like $8 if I go before 2.
So $8. So if you took a date to a movie and didn't buy any concessions, just paid for the tickets, that's $16 right there, right? Are you allowed to go to the movies right now? No, you're not. I'm not even allowed to go to Starbucks, right? You don't have to drive to class either. Do you drive yourself to class?
No, I bike it.
You bike it. Okay, that's
I have a bicycle. Yeah.
That's good. That's good. You don't take the bus either. That's good. Okay. Yeah, I'm just trying to think, where you could save some money so you could buy StatCrunch. So I mean, I haven't been to a gas station in 6 weeks. 6 weeks. I'm still on a quarter of a tank.
No, I get what you're trying to say.
You know what I'm saying? Like you've been saving money by not eating chips at the student store, by not going to class. You've actually saved probably a lot of money over these last month or two. So it might be a good investment to see if you can get that for $15. So that's kind of how I look at it too, right? Like I get paid to be here, but they don't pay me for my gas, right? So instead of spending $1,000 in gas for the month or whatever it is, $500 in gas for the month, I'll probably am going to reinvest that into a better computer, because I don't expect the company that I'm working for to buy my gas for me. Now they pay my paycheck, but I don't expect them to reimburse my gas unless I'm doing it on the clock. I don't expect them to reimburse my car payment either, but I need to get to school. So these are just things that I know I need to get for my daily existence that will help me earn money. So I just chalk those expenses up to like daily living expenses, if that makes sense. So there are certain things that I will just invest in just to make my life easier, I guess. I don't know. Anyway, just rambling, because I don't have any friends and they don't really let me out of this room ever. So you guys are it. That's all I have. Me and my dog. So very sad. I'm just kidding. I have a family that I live with, but I don't know. Maybe they don't like me. Who knows? Every time I come out, they're like, go back in your room. I don't know. I'm just kidding. Okay, anyway, I'll stop my rant on why certain expenses are okay. They're okay to spend money on. Okay, like sometimes you just got to have that donut. You know what I'm saying? Like you just got to have the donut. It's not a necessity. I know it's not a necessity. But when that Krispy Kreme is lit up, okay? When the Krispy Kreme light is lit up, there's just something about it that says, I need to stop because there are warm donuts that are calling me and calling my name. And do I need to spend $10, $12 on a dozen donuts? No, I don't. I don't need to do that. But am I compelled to do that? Yes, I am. I am compelled. So at any rate, if you have questions, please let me know so I can shut up at some point. Otherwise, I'm going to bolt it and I'm going to Krispy Kreme right now. Because guess what? Did you realize that Krispy Kreme is considered an essential business? It's an essential business. Who knew? Who knew? Right? What I considered essential? Probably not. Probably not. But it's food. And to someone, it's essential. The Krispy Kremes are essential. Okay? The Winchells is essential. Well, that I understand. I understand that Winchells is essential because of the coffee. I mean, you can't have your donuts without the coffee, and the coffee you have to do your job running on caffeine. So I get that. And I know that Krispy Kreme probably sells the coffee too, but I don't buy the coffee. I just go for the sugar. The pure raw sugar. You can just inject it right into my veins. That's it. I'm good. I'm up. I'm ready to do my statistics now. Bring those Krispy Kremes home. Bring them home. For me. That's it. Anyway. Buster agrees with me. Don't you, Buster? He does. He's looking at me. He's like, I don't know what the hell you're talking about. You just need to be quiet. And that's what I'm going to do. Okay.
Professor, are you still there?
Sorry, what was that?
So I bought StatCrunch. Can you help me like how to navigate it? How I'm trying to get a
Sure.
the standard deviation and mean.
Okay.
Can I share my screen or?
Yeah, absolutely. Yeah, please share your screen.
Can you see it?
I can, yes.
Okay, so how would I get, because I'm doing this problem and it's asking me, I have to enter all the data manually and get the standard deviation and the
Right.
mean. So how would I do that here?
Okay, so you entered the data. Let me see the data again. Okay, so team 1 is this one and team 2 is this one. Okay, so unfortunately, you're going to need to copy and paste the second row.
Mm-hmm.
Okay, so highlight the second row
And put it down here.
and then pull it. Yeah, exactly.
Okay.
Because it needs to be all one team. Does that make sense?
Okay.
And then no. Hold on, what are you doing here?
Well, I was gonna put 2, 3, and 4 under 1.
Yeah, do 3 and 4 under 1 as well.
Okay.
I'm glad I could convince you to buy it. So that's good.
I was really stingy. I was like, oh my god.
Yeah.
But I was like, President Trump gave me $1,200, so I was like, I'll use that for that.
Exactly.
All right, so it's in there. Do I have to call this one in the second, or no? Not yet.
Okay, so where's team 2? Team 2 should be in the second where it says var 2.
Okay, so I'll just.
Okay, that looks good. So yeah, no, exactly. Perfect. Okay, so see if you have the same number of data in. So how many pieces of data do you have? Oh, maybe one's different than the other. You have 50.
Yeah, this one's a little bigger.
It's a little bigger. Oh yeah. Okay, that's perfect. Okay, awesome. So okay, so now we want to find what? We want to do
the standard deviation for team 1, and then so I need to get the mean, the standard deviation, and the sample size, which the sample for this one is 56 and this one's 62. So I just need the standard deviation.
Go to stat.
Okay.
Okay.
Do I have to highlight anything or just?
Go to summary stats and go to columns. Okay, and then select the column that you want. And then select the statistics that you want to be reported. You want the mean. Okay, you want the standard deviation.
Oops.
There you go. And then compute. Okay, and that will give you for the first one. I wonder if you could do this. You might be able to do it for both. Try doing that again and then run it for both var1 and var2.
Okay.
So stat. Summary stat. So yeah, select both of them. And then you could just hit compute. It's going to calculate it anyway.
Oh, okay. Okay, cool.
Boom, and yeah, there you go. It tells you that 56 is in the first one, the mean, the standard deviation, and 62 is in the second one, just like that. Okay.
do I have to keep the whole entire decimal, or can I round by the second or third one, or just keep?
Well, it should tell you what it wants you to round to.
Well, this is just the first part. Then after this, I have to calculate in the two sample.
Oh, okay. So you actually don't need to calculate that.
Oh, okay.
That it'll do it all for you at the same time.
Okay, so how would I do that?
So you go to stat
Hmm.
and then go to T stats and go to two sample with data. There you go. And it says sample 1 is var 1. Sample 2 is var 2. Okay. And then we want to do hypothesis test.
Here's the thing.
What do we want to do? Hypothesis test? Yeah. Mu1 is equal to mu2 and mu1 is not equal. So we just want a not equals.
Not equal.
Yep. So
Okay, got
that's
it.
correct. That's correct. And then hit compute. Okay, and it tells me that the sample difference, that's the T stat,
Mhm.
okay, is 2.04. The p-value is 0.04, okay, which is bigger than the significance level that they're asking for.
Yeah.
Okay, so yeah.
Okay. Let's see. Let me see this one here. So the p-value for this one is 0.0434, but according to this, the answer was supposed to be
Oh.
0.0428.
Oh yeah, I think something was checked that shouldn't have been checked. Go back to the summary. Okay, so uncheck pool variances. We don't want that.
Is that something that's always going to change, or it should always be in check?
It should always be unchecked.
Okay.
Yeah, I don't know why it was checked. Maybe just the first time you use it, it's checked. Who knows?
Okay.
But
Okay. Cool. I'll do that one. And then for this one, do I do that? I was getting
Okay.
0.27 on two different things, but when the answer was telling me it was 0.43.
Right. Okay, so we want the 99% confidence interval for this, right?
Uh-huh.
So go back to StatCrunch.
Okay.
Okay, and then we want to do stat, and we want this was a proportion. Were those proportions, or was it T? No, it's T. Sorry, it's T. It's means. So T stats, and then two sample with summary,
Okay.
and then we just plug in the values that we have, 20, 231, and 0.31.
And then there'll be a confidence level of 99. Computer. So 0.42 plus or minus. So the standard error is so it's 0.42 plus or minus 0.14, right? Because it's the
Right.
okay.
So it'll say, yeah, well, no, it's your standard error times your t score. So what we have to do here, okay, is we have to find the middle point. So we have to actually do some the sample difference is 0.42. That's what they're saying.
Yeah.
Okay, so that's the middle, right?
Mm-hmm.
Okay, so the sample difference is 0.42. So what we have to do is we have to take the upper limit minus the sample difference. So we
Minus.
want the upper limit, which is 0.798, or roughly 0.80, basically, if you wanted to
Mhm.
round it. It's 0.80 minus 0.42. That's going to get you your margin of error, and that's what they're looking for. So it was 0.38. Is that what it was? Yeah, that makes sense.
Okay.
Okay.
Okay. Yeah. I mean, this is way easier. I should have just bought it a while ago.
Yeah.
Okay. Cool.
Okay.
Thank you, Professor.
Yeah, absolutely.